Imagine a brain that doesn't just function, it rewrites the rules of neuroscience. This isn't the beginning of a sci-fi story, but a reality that scientists are already encountering. The brain we're talking about doesn't belong to some kind of superhuman, but to artificial intelligence. Or, to be more precise, to a brain model created with such precision and complexity that it's already helping us understand things that have remained mysteries for decades. Let's take a step back. Neuroscience is one of the most mysterious areas of science. Despite all the progress of recent decades, we still struggle to explain how exactly thoughts, emotions, and memory arise. Yes, we can track electrical impulses. We can see which areas activate when solving problems or during sleep. But that's just the tip of the iceberg. Now imagine, we create a digital copy of the brain so precise that it can learn, make decisions, and behave like a real brain. One such project is the Blue Brain Project. Scientists from Switzerland have been working for over 15 years to recreate the brain structure at the level of neurons and synapses. That's hundreds of thousands of digital neurons, millions of connections, all of it functioning, interacting, and evolving. Why is this needed? First and foremost, to understand how our own brain works. Imagine a simulator where you can model depression, Alzheimer's disease, or schizophrenia. We can observe how exactly the breakdown happens in the circuits. What triggers the deviation? This could lead to fundamentally new treatment methods, not for the symptoms, but for the causes. But there's also a more futuristic aspect. What if such a digital brain can not only replicate our functions, but surpass them? What if we create a form of consciousness that evolves faster than we do? Some neuroengineers are convinced it's only a matter of time. Even now, models based on the brain's functioning principles are being used in AI development, neural networks, and even in robotic control systems. And the more accurately we understand how the biological brain works, the more effective these technologies become. Here's an interesting paradox. The more we study the brain, the more we realize how different it is from a computer. It doesn't just transmit signals, it adapts. It changes under the influence of the environment. It rewrites itself. This process is called neuroplasticity. And now, as we try to bring this into the digital realm, we have to reinvent the principles of computation. It's no longer just zeros and ones. It's learning from experience, from mistakes, from the outside world. There are real examples of how these models are already changing medicine. For example, neurointerfaces. People who have lost the ability to move or speak can now interact with the world again, thanks to devices that connect directly to the brain. This isn't science fiction. This is clinical practice. And behind these technologies are the very brain models that allow us to decode signals and turn them into commands. But of course, it's not all so simple. These discoveries come with serious questions. For example, if we create a brain model capable of self-awareness, will we be obliged to recognize it as alive? And if so, what rights would it have? These are questions not only of science, but of ethics, philosophy, even politics. Some scientists believe that in the next 20 to 30 years, we'll be able not just to simulate brain function, but to transfer consciousness into a digital environment. Imagine that you could preserve your personality, memory, and experience, even after the death of the body. And all of this would be thanks to understanding how exactly the human brain works. Such a brain, whether created artificially or modified through technology, really could change the future of neuroscience, because it becomes not only the subject of study, but also a tool for studying itself. It's as if a telescope started looking into its own mechanism and improving it. We are standing at the edge of an era where the boundaries between biology and technology are blurring, and the brain that will change neuroscience might already be learning, evolving, and waiting for us to be ready to understand it.